So let's jump right into it. Today we're going to discuss some of the applications for Propeller CAD models, and there are three categories that we're going to touch on. The first is visualization for 3D models, for concepts and mock-ups, product development, and things like that. The next topic will be simulation, such as CFD and FEA, which is computational fluid dynamics and finite element analysis. And then we'll get into Propeller CAD for manufacturing operations. That includes casting, CNC machining, etc. Each of these applications has a different objective for representing the Propeller data, and as a result, we may discuss how these requirements affect our CAD models. Before we get into each application, let's give some background on the typical aspects and characteristics for communicating Propeller design data. As with today's prevalence of personal computers and CNC machining, 3D CAD models have become the most common way to communicate 3D data. 2D drawings and offset reports are still used to supplement 3D models. Well, actually, in fact, they're essential because they often notate the design parameters of the propeller that are not obvious from the CAD model itself, blade area, things like that. Still, the reality is that the data will eventually be represented in a computer again at some point. So if we communicate our data in 3D formats, we can eliminate errors that might occur during someone else's recreation of the data from drawings or offsets. And so now we'll talk specifically about 3D CAD models, but I just want to point out that 2D drawings, offset reports, and the parameters that they include are still very important to CAD models.